Welcome to Made in Science, the official podcast of the University of Stuttgart. My name is Wolfgang Holtkamp. I am Senior Advisor on International Affairs and your host today. In this episode, we welcome Junior Professor Dr. Hanaa Dahy. In her home country, Egypt, she acquired a bachelor's and a master's degree in architectural engineering from Ain Shams University in Cairo. Already during her studies, she founded her own architectural office, also in Cairo. However, in order to pursue her PhD degree, she came to the University of Stuttgart in 2010. After finishing her doctoral degree in 2014, she decided to stay in Stuttgart and started to work as a researcher at the Institute of Building Structures and Structural Design. 2 years later, she founded the section Biomat that focuses on bio-based materials and material cycles in architecture. Bringing together design and sustainability has been her key priority for years. And so it is no wonder that she is not only an award-winning architect, but also a passionate inventor of new materials. We are very much looking forward to hearing more about Professor Dahy's research and her goals for the future today. Hello, Hanaa.
Hello, many thanks for the invitation.
Hanaa, I just mentioned that you come from Cairo, and Stuttgart and Cairo are sister cities. I've been wondering, how do you experience the twinning of these two cities?
Well, the twinning for me as a wording was known maybe later, even after coming to Stuttgart. But it was known for long years during this cooperation between the two cities. And as a reflection to this twinning, I came here and many colleagues went there back to Egypt and back to Cairo. So let's say that the wording itself was a motto at the beginning, but it turned into a practical experience later. I have a lot of experiences in that sense, and knowing so many people who already went from Cairo to Stuttgart based on previous experiences of other scholars and professional people working on both sides of the cities. And even back from the German side, I know quite well from a friend who is a lawyer in Cairo that many German professionals have turned and moved to Cairo to work also there. So the practical experience shows quite well that the twinning really took place, and we don't even need to say the motto anymore because the practical experience and the real life is showing that.
When you say practical experience, that brings us to your life here at our university. The focus of your research is sustainability. What exactly are you working on, and what do you think you are known for?
I think I'm known for the motto, which is getting materials as a start for the designing process. That's another alternative of what we're used as architects to work with. Normally, even the way I studied, and it was known for a very long time, that you as an architect, you start by making geometries first, and then you move it on to a civil engineer who should make the calculations, and then the process goes linear. But then working the other way around, that you start to see what are the kinds of local resources you have in the first place and think of how this could turn into a geometry. This makes you even go more deeply in knowing what are the fabrication technologies that could lead to certain kinds of geometries rather than others. And the whole way is then turned and reversed into a kind of something that we call circular design. And then shifting all that means that for me, back as an architect who would really like and love to make a difference, that means that I really need to educate myself much more in the area of resources, materials, and how to pursue innovation on that level in order to get it back as a high level of innovation in architecture and to reflect new ways of how we can make our buildings. And that's why understanding what a sustainability could mean, that we could reduce the burden on the future generations, we really need to make a good action and in an innovative way. We don't really need to work the same way that even our professors who used to teach us in a specific way. It was correct and good for that time. But technologies move so fast in a way that we have to catch on, and we have to educate ourselves what's happening also in other kinds of industries than the building industry. And from that, it became known that resources it would not last for long, and we have to go in the area of renewable resources, not even normally renewable resources, but annual ones that are really, that kind of guaranteed that it is an annual thing and that it is available as much as possible. And then we could have a goal there to try to find a way to fabricate it in new innovative methods that could turn us back to an innovative architecture. And through this, let's say, less burden for the coming generations on what we leave from destruction that is unfortunately known for the building industry.
Do you think that architecture is only gradually understanding this, that the importance of sustainability in architecture is being stressed? Or how long has this, let's call it rethinking, been introduced already?
That's a very nice question. The point is that for many years, the word sustainability has been known, but it was taught only from the area of how to introduce natural lighting in buildings or certain kinds of thinking of how to introduce the sustainability as a factor in the buildings. But talking about resources specifically raised a lot even in the last years because of digitalization and having the tools now at last to make things really happen. In the past, there was always this ambition, but it was, let's say, not that radical and spread in the way we understand the wording. But at the moment, and after having even seeing ourselves, what does it mean to have melting taking place on the poles and the very large destruction of the known forests that have been there for centuries, and now all of a sudden the very big fires that happened in the Amazons and in South America and so on, this caused extra attention to what's going on in a visible way that nobody can ever deny. Also the spread of diseases in this dramatic manner, that is all a reflection to the huge destruct of the environment, and nobody else can now deny such a thing. And since it's known that the building industry is responsible for almost the highest ever destruction of the environment among all kinds of industries, now there is no more chance that one can deny it, and there should be a real movement in a kind of solution. And having a solution by the presence of digital tools and all kinds, whether fabrication methods or design methods or construction methods, all those needs to be connected. And that's why there is a very big movement in different architectural schools worldwide in that area.
To improve the situation, you said it needs the products that are necessary to make a difference. You invented a flexible, high-density fiberboard and also a method for manufacturing it. And here it comes. The fiberboard mainly consists of straw. Please, can you describe how you developed the fiberboard and tell us what it is used for?
The fiberboard has a small story that, back again looking at resources, what kind of resources do we have? It was very clear that almost the only resource that is available worldwide without even a region that don't have it, literally worldwide, is the rest over of all kind of crops agriculture. Because it is a main thing, cereals production for nutrition, that's a main thing to do, and that is cultivated in all different countries around the world, whether we're talking about wheat or rice or whatever kind of cereals. And the restovers are huge amounts of so-called straw, which is the restover of the plant itself that holds the grain inside it, the cereals. And getting into that point, having a fiber in hand and seeing what we can do with it. As an architect at the beginning, it wasn't so clear how far can we get to something, but it was clear through the knowledge of understanding from calls and communication with other disciplines from the material manufacturing industries and from nutrition colleagues, also the ones present in the University of Hohenheim, it was very clear that the inside of the fibers are just cellulose and lignin and hemicelluloses and all the known components that is normally known in timber. And by knowing that knowledge and going deep into that, seeing, okay, how we combine the materials together, the composites was the answer for that. And the different ways of production of composite systems and composite materials, that was the start or the click of trials. So knowing that info, it was possible to start initiating cooperation channels between different institutes, including the one of Fraunhofer Institute for Chemical Technology in Karlsruhe and many other kinds of research-oriented organizations in Germany. And through that, the cooperation started, and I started collecting then the materials and getting it in big bags and getting to those institutes to make my trials. And each time there is a failure, there is a very big lesson to be learned. And through that, it was possible to understand that because I'm always thinking about a material as a designer in the first place, not as a material engineer. I'm not educated for that originally. But then through self-learning, it was possible to understand what does it mean to have a compatibility between a fiber and a matrix, a binding material, and what does it mean to have a certain dimensioning or geometry, what kind of tool of fabrication could be ever used. And understanding that from different disciplines, it became very clear that a production of those kind of cellulose fibers was missing to have it in a huge amount to be recycled. And that was the thing that clicked. We need to have a very large amount by weight, because there is a difference between amount by weight or by volume. By weight is the one that would make a difference economically, because we need to, or the farmers need to sell this product. They will not see it anymore as a rest-over product and burn it in open fields, and that is what is happening in that field. So it's solving another problem in another field, which is in the agricultural management residuous area. And then understanding that we need to recycle as large as possible amounts of that material and get it back to the area where we really need it, and we're having less resources and less alternative materials. And through matching different disciplines, the multidisciplinarity is the key. So matching different disciplines and understanding more and more about the technologies of production made it possible to have a large amount of the fiber compacted, condensed, and binded together with something called elastic thermoplastic polymer, which is a thermoplastic polymer that could be recycled, but also elastic. It has a level of elasticity because, back again, as a designer, I need something through which I can make freeforms and nice geometries and so on. And then it all clicked in that way, knowing many producers in that field who did not have that base idea, because either there is a big problem in the waste management area, and then I found people actually preparing those kind of fibers but for animal nutrition and not for what is originally needed. So back again, multidisciplinarity and getting communication with many people in different directions. This what made it possible to have this high-density fiber board and knowing in which way we can manipulate its production to make it economically feasible.
This would also include to show the results and to communicate the results of your research, of your work, of your institute's work to the general public. And here at our campus at the university, the Institute of Building Structures and Structural Design with the Biomat section is very well known for its futuristic-looking pavilions that we can see each year, new ones. A few of them, as I mentioned, are placed on campus. Students are included in the design and manufacturing processes of those pavilions. Why is it important to involve students at an early stage of their studies? And what is your goal in conveying your methods to them?
That's another very nice question about the visibility of our work and how do we communicate with community members and with normal users. For me, for the Biomat specifically, it started first before the pavilions and on a smaller scale in certain objects and in smaller mock-ups and even chairs to showcase how if we make a chair that is very lightweight of that new material and as if it's acting as a small structure system. And having a human being sitting on it means it's a loading condition. And then we know that if a human being up to 100 kilograms sat on a chair with a special structure system or a special new material that weighs all the chair all over like 1 or 2 kilograms, then it's a big win in the area of lightweight structures. And it's a very good exercise to know what kinds of new systems could be made on that small scale. And that it started that way at the beginning, and then we went over into so many exhibitions in Hannover Messe, in the one in Stuttgart, in Paris, in Sweden, in many countries all over the world. And it even went to Shanghai in China to exhibit what we're doing. And based on the reflections that we got, I decided to go bigger. At that time, and before I even started my first pavilion, the colleagues who are in the ICD, Achim Menges, and from ITEC, Jan Knippes, they were already bonding together their experiences and doing the master program named ITEC and working along in that way in a different dimensioning of applying materials and making pavilions. And it was for me very clear, since I joined them the same group somehow, that it is a very good possibility to reflect instead of having smaller mock-ups in exhibitions, to reflect even on the campus side what we're doing on larger scales. And then it was a very nice possibility also to gather students from the main master and bachelor German stream and to give them also the chance to have this kind of alternative thinking from the material. So the difference was there that the students understood what does it mean to start by a material and express themselves and know that based on the experiences of the users' reflection in the Hannover Messe and in other exhibitions, it was clear that the people are really waiting for such a thing. Also because as an architect, as a future architect for those students, they need to know that by default they need to educate themselves in the new systems, in the new directions of architecture, and that time really changes very quickly. Also, it was very clear that the digital tools that they have to learn very good, they also have a reflection not only on the design as geometries only, but on understanding how things are made, how they are fabricated. So all that helped them out to play a part in it.
The English-speaking master program, Integrative Technologies and Architectural Research Design, ITEC, that you mentioned, is a very popular program among international students. Now, it is not only the students who are involved in the early development stages, but also the industry. Why is that important?
Well, in the ITEC program, there is a tradition that Jan and Achim have taken, which is that they have a cooperation with the University of Tübingen, and they're applying biomimetic principles in the constructed work that is done normally per year. And the industry play a role, I think, in the kind of materials applied and the systems that they are applying in their constructions. In my case, the way I'm involved in this program is specifically through a seminar that is called Material Meta Lab or Material and Structure, where I guide the students through this journey of the different way of dealing with the design process in dealing with materials as a design tool, and we're making the smaller mock-ups. But then in parallel, I'm having my design studios that are open not only to international students, Erasmus students, exchange ones overseas, but also to the German students of our university, and giving them the chance also to play a role in that sense, in the sense of having materials as a design tool. And then depending on the kind of research that I'm having at that year, I guide it, or let's say combine it together with teaching. So research with all the industrial partners involved in that research are combined in teaching, and they're giving very fresh ideas of what is happening in that project at the same time. So if there is a project linked to pultrusion, to make pultruded profiles. That's why the last pavilion of the Biomat Pavilion of 2021, that was constructed by pultruded profiles made of very freshly innovative, newly produced natural fiber profiles. And that's why this was the topic that was the case for 2 design studios that were successive in 2 semesters. One to find the designs based on the understanding of that kind of material, and the other semester was for construction. And that's why the opening was done in the summer of last year, 2021, based on that concept. And that's the other way of the involvement of industrial partners in that sense.
You grew up in Egypt and worked as an architect in Cairo in your own office after having acquired a bachelor's degree. Given that context, was there a specific experience back then that led you to shifting your perspective to sustainability in your work?
Well, it was a kind of a sad story. During the studies as an architecture student, it took like quite a couple of years, like 3 or 4 years, not to go back to my, let's say, very special city in Egypt. I'm originally from Cairo, but I've always experienced going there into Alexandria. We have a small apartment there, and we always go in summer, like real long time, say 3 months per year. So it's quite a long time to experience as a child, having my special area, special shore, and so on. And back again, having the 4 years of a time that I wasn't able to go to Alexandria because I was always caring in the summertime to have extra training in the area of architecture and so on. All of a sudden, after 3 or 4 years, I went there, and I was by default going to where I'm used to go as a child, trying to see the seashore, my very special one. And then I didn't get it. I didn't get it where they moved it or what happened. I mean, I went back and forth and realized it's not there at all. And found instead of it very large concrete blocks. And after asking people, even the street, where is this place? I thought I'm wrong. And they thought, it seems you've been a couple of years not here. It's not there anymore. And then it was a real shock. It was very sad. And I didn't get it. How come that there is a full shore that all of a sudden, really, it's just 3 or 4 years. It's not a century. And it has just disappeared because of the rise of the sea level. Why is that? Because of the environmental destruction we're living in. I mean, to that extent, it was like a punch in the face, to that extent that it is very quick that I even lived it, and I didn't need to wait for 10 or 20 years. It's just a couple of years that this was so apparent and visible. And then it like shifted to my mind. I already studied architecture. I cannot study now anything else, but I can through it have it as a tool to make maybe an impact or a difference, to make this at least less destructive. And then I went into understanding more and more and visited many ministries in Egypt that has to do with the area of environment, and started collecting data, and wanted to do this originally in my master's. But then I worked in my master's about physical modeling and fabrication techniques based on it, and reverse engineering in that area to visualize architecture, and then decided afterwards that I would travel abroad to find answers for the question of how to go more sustainable for real in architecture, and how to make this possible, at least from my point of view, how to have a perspective in that, and how to help the coming generations even with a small impact. And that's why I took it seriously and went into that path.
In your education, you went to the American high school in Cairo, and therefore you grew up within a very international environment. How did that influence you and your life?
Well, at school time, it was the ex-American college in Egypt, which is now called Ramses College in Egypt, RCG. That's a trilingual school. Trilingual means that you don't have only bilingual, it's trilingual. You have 2 other foreign languages that you practice as a kid, along with the original mother tongue language through all the years. And in this school, I went to kindergarten and to all the basic elementary school, and to all over till the Abitur, or the very last degree that we need to have before entering university. And all that time, I experienced then many languages, but along with, it was mainly English and French, and even my fourth language is now even German. But this made me very well prepared to understand about or to have a wide perspective of what other countries' cultures look like, how people think. And experiencing that, it made a big difference of also expecting what others could have other perspectives in life and way of thinking and working and so on. It helped a lot. But also I have to say that my mom herself, she is a graduate of a French school, and it made a difference also at home to have multi-languages every now and then. We're all talking Arabic at home, but every now and then having this kind of nice terms going around at home, it made a difference, of course, in the way of thinking of having an open world and having no limits. Also, it reflected in me coming here and having this seeing as no barriers. So having even any time for adapting to new environment did not exist, because I don't see it as a new, different environment, but it's a kind of continuation to the heterogeneity of having situations from normal different cultures on a daily basis back there in Cairo.
Hanaa, what do you think the future of architecture looks like?
Oh, that's a very strong question. How the architecture would look like. I would say how would I prefer it to look like. Let's say, I would say that the rediscovery of local architecture, because it will be dependent on local materials. So I don't need to have cement from somewhere else or steel from another maybe continent and so on. I would depend only on what I have. I would be keeping local. But I can add a very nice touch of modernism to that through the usage of the digital tools present in each country. Not only digital tools, it could be very normal, conventional tools, but good enough to make me understand the value of the materials and how far they can be applied in architecture in new innovative ways. The pultrusion, for instance, that we have used in our last pavilion of last year. It was made of, the pultruded profiles were made of relatively conventional pultrusion method. We have used digital tools in order to know how to design with it after knowing the material's capacity. So this process can be done wherever we want if we have this kind of resource. And similarly, each region could have its own local architecture. This local architecture could have the very good reflection of the modern time we're living in, but using the available technologies in that region. This will cause way less destruction to the environment, because we're not relying on having other materials that is not present in my environment. It will react positively to the weathering that I have in that local place, because it is lying in that normal region by default. I would go to understanding of what do we mean by reusability concept integration in our buildings. How can we integrate that? That should be the future. That should be having, as if we're having like open material markets or material reservation for our buildings. We could use parts of those buildings later for another building if we want to deconstruct it. The integration of many aspects that could enable the closed cycle of those new futuristic architecture. It could look fantastic, but again, having the lowest possible burden on the environment. That would what I would really love to see in the future.
In order to make that, I'm not even saying change happen, but to achieve what you have just described, what skills will architects need to have in the future?
The skills are relatively a lot, because the problem is we are facing now a complex problem. We want everything. We want a fantastic architecture. We want it very strong. We want it against fire. We want everything. And having everything in one product is only possible if we have very high level of innovation. And to have that level of innovation, an architect, the future ones, and we ourselves, we have to learn something about everything. That means we have to learn about other disciplines and how to get a good value of integrating our experiences with other colleagues from other disciplines. Because just take, for instance, the concept that what I'm doing at the moment, biomaterials. It was never possible to make this alone. I have to contact too many people from the material industry. I went even in a conversation many times and a direct cooperation with people of nutrition, of animals, because they are the ones who know more about those kinds of rest-over agriculture residuals and how even to prepare it in different densification methods. And went into conversation with colleagues of the aircraft design because they have fabrication tools of different kinds and dealing with fibers also of different kinds. I had to go also in a very direct cooperation with people of the textile industry, like the colleagues of the German Institute for Textile Research, the ITEC in Denkendorf. And endless amounts of cooperation that already happened and will still happen, because without the knowledge from all those people, it would never be possible to come back as an architect to something that is valuable to us and see what do we have in the first place as a resource and find out the way of how to get it back to architecture or to the building industry in a different way. So similarly, the architects of the future need to do the same and even more, because the problem is getting more complex. Also, they need to educate themselves so much about digital tools, understand coding, understand many ways how to use the different tools and how even to create different tools in order to get all those kinds of data and all these kinds of problems in one format in order to deal with it as a communication tool with other disciplines, but also to have a very strong impact on how to control it. The architects are really the bosses, the managers of the whole architecture product, of the whole building product. At the end, even a customer comes and talks directly to an architect to handle this. And an architect has to know all that in order to get it in the correct path.
In your own work, you have European and international patents. You won the Senior Fellowship Award for Excellence in University Teaching in 2016-17. You earned a number of research and industrial project funds, and you are a member of a number of European and international scientific and professional bodies. In one word, you have a long list of badges that you carry. What do you aim for in the future? What else should be added? Which way are you heading right now?
Thanks for making that so much visible for me. It's an honor. But I think that this is only one small step, that a lot has to still be done. The area is of bio-based materials applications in architecture is relatively very young, and it needs so much work still to be done. So many things are still explored, and we're making the upscaling. We need to go further to the market and to get it into back into the hands of the manufacturers to make it more visible to the consumers. And that path is still full of still undiscovered stuff, and this needs to go further and further in the development. So yeah, there are still maybe further dozens of badges that I'm wishing to have, but most important and more important than the badges are the impact. Is the impact for real to be done in that field?
Now we come to the final part of our conversation that has already been full of insights today. This we call Moment 7. We have collected 7 questions that we would like to ask you. Please answer as shortly as possible. Moment 1. Spätzle or Maultaschen?
Spätzle.
Moment 2. One thing you could change about the world.
Impact of the building industry.
Moment 3. Do you have a book recommendation for us?
My coming book. That will be Bio-based Materials in Architecture.
Moment 4. The best advice you have ever received was?
Work hard and you'll get it.
Moment 5. Your favorite building on our campus?
On the campus or in Killesberg? It's the Killesbergturm.
Moment 6. If you could start all over again, you would do the following differently.
I won't do anything different. I would follow the same passion.
And moment 7. Please complete the following sentence. The best thing about Stuttgart is...
Multiculti, multicultural.
Thank you, Hanaa, for this talk. Lots of insights, lots of ideas for the future, but it also feels to me that the future is here right now. And often we say we have to start by shaping it today, but talking to you, listening to you, I fully understand that this is not only a phrase. We are very much looking forward to staying in touch with you and wish you the best of luck with everything you do and everything that can be done when it comes to made in science in your field. Thank you.
Thanks a lot. It was a pleasure.
And to our audience, thank you for listening. Please feel free to subscribe to our podcast and also to rate it. Most of all, stay tuned for Made in Science.